other class. I'm Dr. B, your chemistry teacher. In fact, your science teacher online, because as far as this our classes are concerned, we do chemistry, biology, physics, and mathematics. And today, you and I are going to be dealing with the extraction of aluminium. Okay, we've heard much about aluminium. We've been using products from aluminium up and down. Okay, but today we are going to take ourselves through how aluminium is actually extracted. This is Dr. B Science Classes online, and you owe me a duty or to do what? To just simply subscribe. Subscription is free. Okay, so you just need to subscribe and then you share this class. Most importantly, share this class. Share it to all the groups that you have. Share it to your colleagues, share it to your fellow students and their groups, and ask them to do what? To subscribe. Tell them that subscription is free. That's all you owe me. And then the Facebook page is also there, and it's Dr. B Science Classes. And you should also share through Facebook and ask them to do what? To follow. Of course, to follow me, follow my page is also very free. Leave your comments, ask questions, or even appreciation. All right. And if there are questions, we are going to do justice to those questions. Thank you very much. Now, let us take a look at the extraction of aluminium. Do you know that aluminium is one of the most abundant elements you have in the earth crust? Okay, so on this earth crust, the most abundant element you can think of is aluminium. No wonder aluminium is highly being used for a lot of things. Even in aircraft parts, aluminium is being used. In cables, you find aluminium being used. You also find aluminium used in your cooking utensils, in spoons, pots, and all those stuff. Aluminium is used even in ships, okay? Aluminium is used in roofing sheets. Aluminium is used in a lot and a lot of things. You find aluminium usage right there, staring at you. Okay, aluminium belongs to the group 3 in the periodic table. All right, so if you go to the periodic table, aluminium belongs to the group 3 elements in the periodic table. The aluminium is having an atomic number of 13. Okay, yeah, atomic number of 13. Quite something away from sodium, almost closer to sodium, okay, as a metal. Aluminium has atomic mass, okay, atomic mass of about 26.98. Of course, if it has atomic number of 13, its atomic mass is only more like doubling its atomic number. And of course, it's in decimal because it exhibits some level of isotopy. All right, so aluminium is having a atomic mass of 26.98. All right, and aluminium is quite reactive. It is a metal, so it is silvery white in nature. It's malleable, ductile. Also, aluminium a good conductor of what? Heat and electricity. So just like a metal, it has all these properties. Aluminium as a metal also reacts with acids to give up what? To give up hydrogen gas. So all these are properties of aluminium. More and more properties of aluminium you can read of in your textbooks. But these are properties of what? Of aluminium. Now, it has to interest you to know that aluminium can occur actually as trioxosilicate 4, okay, in rocks and also in rocks and in clay, okay, clay soils. So you can find aluminium in clay soils. You can find aluminium also on rocks, but here it is as trioxosilicate 4. But actually, aluminium is obtained as a bauxite. That as a mineral resource, it is obtained as what? As a bauxite, and that is why we call it aluminium bauxite. Bauxite is simply aluminium 2O3, okay, dot 2H2O. This is aluminium bauxite. Simply put, hydrated aluminium oxide. Okay, so hydrated aluminium oxide, that is aluminium oxide with 2 molecules of water or crystallization, is what you call bauxite. And that is the actual aluminium ore that is being used to extract aluminium. Okay, so So whenever you want to extract aluminium or whatever aluminium sheets or metals that stand around you, they are extracted out of what? Out of aluminium bauxite. And bauxite is simply hydrated aluminium oxide. Alright, simply put, aluminium oxide with 2 molecules of water of crystallization. Okay, so that is aluminium for you, and that is the little we are going to capture from what aluminium is all about. Now let us look at extraction of aluminium. Extraction of aluminium. Aluminium is extracted in 2 principal ways. And one of the ways is the purification of the bauxite, which is actually the ore of aluminium. And the second way is by electrolysis of aluminium, or you can say electrolysis of what? Alumina. Okay, so the electrolysis of alumina, which is the aluminium oxide, okay, itself, or aluminium trioxide, as anyhow you want to call it, aluminium trioxide or aluminium oxide or alumina. So you can use electrolysis to finally extract aluminium metal, pure aluminium metal, out of what? Out of its alumina. And today you and I are going to do justice to that extraction process. We're going to look at both purification of bauxite for us to get the alumina, and the use of the alumina through electrolysis to obtain aluminium metal. That is why you and I are here today. Alright, now in the purification of bauxite, okay, what is first done is that the bauxite itself is what you try to purify. And in the purification of the bauxite, you have to do what? You have to react it or mix it with what? With caustic soda. And caustic soda is sodium hydroxide. So it means that once you take the bauxite, which is a hydrated aluminum oxide, and dissolve it in sodium hydroxide, which of course is a solution, you add some extent, you add some amount of water, and then you heat gently, you are going to obtain what you call sodium aluminate. Now, sodium aluminate is the product that you will obtain when bauxite is heated with what? With caustic soda. So once bauxite is obtained from the soil, okay, so bauxite is going to be crushed, and then once it's crushed, it is going to be dissolved in some amount of water and then dissolved in caustic soda, which you popularly call sodium hydroxide. And once that is done, heat is applied and you obtain what we call sodium aluminate. Sodium aluminate seems to be quite impure. Of course, you can see amount of sodium with it and hydroxide with it, then aluminium. And there are other type of impurities, especially impurities of silicates. Remember that I had mentioned earlier that one way you can have aluminum deposited is as trioxosilicate. So you can have aluminum silicates, aluminum trioxosilicate depositions in soils and also on rocks. So even as bauxite, you can also have impurities of silicates and other impurities present. So with your dissolution of bauxite in sodium hydroxide, that's caustic soda, and water, heating it to give you sodium aluminate, there are still impurities of trioxosilicates and other metals that come with them. Now, with the presence of this trisilicate, with the presence of this sodium aluminate, you need to do what? You need to remove those impurities. Now, to remove those impurities isn't a problem. Remember that the impurities are quite lighter than the sodium aluminate itself. So you can simply do what? Simply sieve and filter off the impurities from the sodium aluminate, which is of course a solution. All right, it's quite a solution. So you can simply sieve and filter off what? Filter off the impurities from the sodium aluminate. Now, the sodium aluminate that you have obtained after the sieving and filtration, the sodium aluminate that is obtained is going to do what? Is going to be seeded in a way. Okay, it's going to be seeded in a way, and then you obtain a precipitate of aluminum hydroxide. Okay, so now this is more like a decomposition reaction, so to say. So you have aluminum hydroxide collected and sodium hydroxide also collected. Now it means that the sodium hydroxide that is used with the bauxite can actually be recovered and reused. Okay, so when the sodium aluminate here is seeded, you can have sodium aluminum hydroxide and sodium hydroxide. Sodium hydroxide as caustic soda can be reused for the other processes, while the aluminum hydroxide can be collected. Remember that aluminum hydroxide at this point is more like still a liquid form, so it can be crystalline. Okay, it can be crystallized in nature. So at this point, collected as precipitate, it is going to be what? Going to be dried, washed. Okay, but let's say it's going to be washed and then dried. All right, and when it is dried, it is now going to take the next batch, which is going to be high temperature heating. Okay, more like pyrometallurgy. All right, more like pyrometallurgy. So you're going to have a high temperature heating of this aluminum hydroxide after it is being filtered off, washed and dried. So you're going to do what? Carry out a pyrometallurgy, that is high temperature heating of this aluminum hydroxide, and you are going to have what is called alumina. Now this aluminum oxide is called alumina. Now this first process of purification of bauxite will leave you with alumina, that's aluminum oxide. Now you are not extracting aluminum oxide, you are rather extracting aluminum metal. So for you to obtain aluminum metal, you now make use of the electrolysis of aluminium. So the electrolysis process or electrolytical process make use of what? The alumina obtained from the purification of bauxite. Now let's see how this process works out. Alright, I have to clean this so we can see how electrolysis of alumina works out. Now, electrolysis of alumina has this. Okay, now I must let us know that the electrolysis of alumina makes use of what you call the Hall-Heroult process. So what we are trying to put up here right now as the electrolytic process for the extraction of alumina from extraction of aluminium from alumina is called the Hall-Heroult process. So anytime anybody asks you to discuss the Hall-Heroult process, is asking you to discuss the extraction of aluminium using electrolytic process. Okay, so here we have this, and this is the steel cell. Okay, so I have the steel cell. This is too high. Okay, so I have the steel cell. All right. We have the steel cell, and then we have a lining. We have a lining here like this. We have a lining, okay? We have a lining here. And we also have, in here, we have a solution, okay? We have a solution. And then we have a drop down. Something good rather. I'm not too good in drawing, so okay, so we have this, and then we have a drop down from this point here. So we have some sort of this positive, and then we have some sort of this positive, and we have another one positive. All right, something like this. This is the Hall-Heroult process for the extraction of aluminium from alumina. All right, so now with this that we also have now we're going to have a deposition. We have a deposition here, and from this corner we have an exit. Okay, we have an exit. This exit brings us to collecting the molten aluminium, the molten aluminium metal. Okay. Now, this is actually a graphite, anode. Okay, so that is why, of course, that's why it's positively charged. And this lining is also a graphite cathode, so it's negatively charged. Okay, and then this solution here, okay, this solution, the solution you find in here is actually molten aluminum oxide, which is the bauxite, plus molten cryolites. Okay, molten cryolites plus molten cryolites. Okay, that is the solution you find in there. And then of course, this wall that you find here, like I said before, is a steel cell. All right, and then of course this deposition that we have here is the molten aluminum. Okay, itself. Okay, so you have this kind of a picture, a diagram that explains the whole Heros process for the production or the extraction of aluminium through the electrolytic process. But of course, you can see that the aluminium oxide that you have here is going to undergo electrolysis. Of course, if it does, the oxygen that you have here will react with some amount of water or hydrogen that you have here and form water. Of course, so the oxygen is negatively charged, so of course it's supposed to migrate toward to the positive anode. All right, here. So the oxygen is collected at the positive anode, while the molten aluminum is collected, of course, at the lined graphite cathode, being that it is, of course, positively charged. So the aluminium metal, molten aluminum, is collected at the lined cathode. That is why it is here. And then the oxygen is collected at what? At the graphite anode, being that oxygen is negatively charged. And of course, you're going to have an exit where the molten aluminum is being discharged. Now, this is a simple way in which, or by which, molten aluminum oxide, which is the alumina, can actually be used through electrolytic process at the whole Heros process, of course, to obtain the molten aluminum metal. But why are we using cryolite in this reaction? Cryolite is very important. Do not forget that aluminium itself has a high melting point. So it would take so much heat for you to be able to obtain aluminium through this process. So the molten cryolite acts as what? As a factor that will reduce the melting point of aluminium and the energy requirements of the system for you to obtain the molten aluminum metal. So whenever you are being asked why cryolite is used in the extraction of aluminium electrolytically, it is because it helps to reduce the high melting point of aluminium and the energy requirements, and stabilize the energy requirements of this system. Now, this is the possible way that you can comfortably extract aluminium. I'm sure that I have done justice to this class, which is the extraction of aluminium following its purification of bauxite and the electrolytic process of the alumina using the hot Heros process. It's nice having this class with you today.